just what unit to use. Unfortunately, some people didn't even, well, let's go on, and we'll get to that next. All right, so the test on Monday is going to cover the whole class. Now, one problem, a lot of people seem to be having problems with getting things uploaded, which wasn't the case when I did a quiz last week. So I'm thinking that the storm might have had a lot to do with that. But I'm going to try to figure out what can be done efficiently if your thing doesn't upload. We didn't have to upload the other class did. The other class did have to upload work. And so that was sort of a test run, you might say, for this class, and I thought things would go just as well, nicely, but the other class had problems too, probably because of the storm. Now I'm going to try to figure out something that can efficiently handle such a thing. One important takeaway message that I got from all the emails is, if you are having trouble uploading it and you're running close to the time limit, send me those things by, well, I say right now, email is the only thing I have going for me. One of the students suggested a Dropbox, but I haven't. First of all, I need to be real sure about how to get the whole class involved in the Dropbox, and that might take time, but fortunately we do have a good few days before Monday rolls around. So definitely, if you have a problem uploading to the Blackboard, either email if worse comes to worse, or the Dropbox, and do it immediately, because I have no way of knowing whether you just kept on working on the problem until you finally got around to telling me that you had a problem. Yeah, I mean, that's common sense, people. I do need to know how much time you took, because I do take points off. By the way, I was really lenient. I took only 1/4 of a point off for each extra minute. That's because it's quite a few students had trouble with that. All right, so these are the practice problems. You don't have to worry about 3.2, the only thing there is putting together the general solution for the associated homogeneous equation and the new equation, the non-homogeneous, the particular solution for the non-homogeneous equation. So here are your problems, practice problems. You've had them before, and I might, however, give you a problem in converting units. I'll do that. I'll send you an announcement on Blackboard if I do. Okay, next slide. Okay. Common mistakes on quiz 2, forgetting to convert inches into feet. I even told that specifically, be careful, don't forget, be careful, convert inches into feet, and I even told you 12 inches make a foot. That's for the benefit of people who grew up in the metric system. But still, some people forgot. Using pounds for mass or slugs for the force of the dashpot. Force is in pounds, mass is in slugs. Yeah, that's a huge difference between the metric system and the the English system, and it does make sense to use different units for mass for force, because of the example I gave. On the moon, your mass is still the number of slugs you carry around, but your weight is the force. Well, we have to upload separate files. All right, now this is a big issue. This is a big issue. My suggestion is sort of a compromise between two things. When you finished one problem, or enough problems so that you think you might need more time, you might not be able to finish the test in time, what I would do is first I will put them separately. I will put them separately for grading purposes. That way you can see what you did on each problem. However, as far as what you upload, some students have already done this. They've uploaded all 3 problems at once. And then sometimes, well, one option is to upload part of the test and then keep working on the rest of the test and upload the whole thing that you have when you think, well, I haven't, either you're happy with what you have and you're still within the time limit, great. If you're not, well, now you have to think about the trade-off. You get a point taken off for each extra minute that you used, and so there's a trade-off there. I mean, it's fairly easy to get extra points within a minute, and so, but here was the other problem. Some students got locked out after a while. That's when the other option comes into play. You average about 15 minutes to scan my submit when my internet is working good. I can't make my internet faster, so if you give us 25 minutes for a quiz, I essentially have 10 minutes to complete it. Now, let's think about this a little bit more carefully. When you start to upload something, yeah, what you can do, here's the thing. Here's where it really comes in handy to upload from time to time. Timer keeps counting while it's uploading, sure, but you can work on the rest of the problems while it's uploading. You see, you start uploading early, that you have 75 minutes for the test. And so you start uploading early and you keep working. Not for the last problem. What's that? Exactly. Well, let me see what this whole chat left says. All right. No, Laplace transformations will not be on the test because you need to have some practice problems on them. And right now, I'm not even giving you any practice problems, but those of you who want to get going on Laplace transforms, since you know, how much time exactly? Well, for this, for the final exam, it's the usual 2 hours and 30 minutes. For the test on Monday, that's going to be half of that, 75 minutes. Will we have to upload separate files? If you're having a good time and no problems with uploading answers to individual questions, just do it that way. And of course, like I was saying, you can start uploading, you can keep working on the same sheet of paper, or you start a new sheet of paper, whatever. And just keep going like that. All right, timer keeps counting while it's uploading. You can keep, not for, I don't know what that was, not for the last problem. Well, anyway. And then somebody says exactly, I'm not sure what's, you could keep working after uploading the first question, but not for uploading the last question. Okay. What you can do is send me an email right away saying this isn't being uploaded properly, and you will, and don't try to put a link in there unless you're sure you can put a link into the email. If you could put a link into the email right away and have the problem there, that's the way to do it. And like I said, well, email again, that's going to be a last resort. You could use a Dropbox up to that. All right, let's one other thing here. The C. You see, you had this thing about the P being equal to C over 2M. And some people thought that they had to make C equal to 8 because right in the original problem, because it was 8, well, 8 feet per second or something like that, but the C is a proportionality constant, you see. The proportion is that you had, well, when we get to it, we'll, yeah, uploading a PDF of the test that will go away after a certain time limit. And then creating another link to upload a single file that is due 15 minutes later. Well, I'm going to have to think about that. That's a little bit. So anyway, what was happening about in the second problem, it was said precisely that the resistance, the damping force is exactly equal to the velocity. So C would be equal to 1 there. It's a proportionality thing and not measured in units of pounds or whatever. There will be other examples of common mistakes as I go through more quizzes, but these are the 3 that really caught my attention. All right, well, I've taken quite a bit of time here for hopefully, hold on, where is this? Why doesn't this slide want to, well, let me go back to the share content. Okay, so this is the next one. All right, this is the second, well, maybe I went one too far. But anyway, okay, this is the second problem. So here is where the mass is 1/8 slug because it was 4 pounds. The weight was 4 pounds. The mass was 1/8 slug. And at 32 feet per second squared is the force of gravity. And so you're dividing a weight by the actual force of gravity in order to find the mass. And of course, that force of gravity is different on the moon than on the Earth. K is equal to 2 pounds per foot. Now, let's see. Yeah, I forgot to actually tell you. I'm going to see if I can repeat the question. Question was, you had, yeah, first of all, the weight was, the damping force was exactly equal to the velocity, so that's one thing. But the K is has other units. The K was equal to, what is it? The square, no, the yeah, K is what goes into the equation. And I was telling you that K was equal to 2. You didn't have to stop and think about that. So when you get rid of that 1/8 there, you're going to get this. You're multiplying through by 8 because you have mass equals 1/8. Divide through by the weight, and now you got a 1 there right in front of the second derivative, and then there was no middle term. Well, actually, there was a middle term in this one. It was the first one that didn't have a middle term in it. The middle term is 8. You have 8 because it's, what is this? Oh, because you divided through by 8. That was the thing there. All right. Well, 1/8, you multiply through by 8, and that's how you get that. That's your C. You got the C. Yeah, this is your C, by the way. Beta is your C here. And yeah, well, yeah. Okay, auxiliary equation. This is it. This is the equation you're supposed to get. Okay, now this has a double root. It's x plus 4, the quantity squared. And so the mass, x plus 4, the quantity squared, is equal to 0. X is equal to, m is equal to -4. And, well, no, wait. What did I really want to say there? The m, wait. auxiliary equation is this. Okay, let's go on to the next slide where that detail is repeated, but now we go on. The solution, you've got, yes, m1 is equal to 4 minus 4, and the other root is also equal to minus 4. So you have to go to this kind of thing. C1 times e to the minus 4t plus C2t times e to the minus 4t. All right, and so so the student wrote it this way, factoring out the e to the minus 4t, which works nicely for some reasons, but not for others. Anyway, plug in x of 0 is minus 1. Now this is something else. I said that it was 1 foot above, and some people, yeah, this was another common mistake, thinking that above meant positive and below meant negative. It's the other way around. You've got that weight hanging from a spring, and so you got to think in terms of the spring being longer or shorter. And the equilibrium position is 0, and negative numbers mean that the thing is longer and it's further down, and the positive numbers, wait, no. Yeah, no, other way around. Yeah, it's something that you just have to stop and think about each time. So I didn't take off too much for that minus. If somebody left off the minus, okay, half a point there. Now, in order to find out what C1 and C2 are, it's not enough to see that what x of 0 is going to tell you that x of 0 is negative 1, is going to tell you, on the other hand, you plug in 0 here and you get C1, so C1 is negative 1. So that's C1 right down there. And then to find C2, you have to take the derivative. So what do? You take, it's best to have it in this form that, I'm going to switch to another color now. It's best to have to begin with in this form in order to take the derivative. That's my opinion anyway. Because then you're observant of the fact that this calls for the multiplication formula, product rule. And then this part doesn't. It's just e to the minus 4t. So here's what you have to do here. You've got C1 is equal to minus 1. And so when I take the derivative of that first term, still with another color now, when I take the derivative of this first term, I'm going to have, but now you're substituting minus for C1, I'm going to get, using the chain rule, you're going to get minus 4 e to the minus 4t, but now you put a plus there because you've got that minus 1 for C1. And so it's still C1 times minus 4 and then e to the minus 4t. Here's where you use the product rule. You get C2 multiplying both of these things. I put the C2 there. And then when you do that, you're going to first have to figure out what C2 is. That's over here, x prime of 0. On the one hand, it's equal to 8 feet per second. On the other hand, it's equal to 4 plus C2. What you do there is you're plugging in 0 back here, so this becomes e to the minus 4t simply becomes equal to 1. E to the 0 is 1. All these e to the minus 4t's are equal to 1, and so you got something very simple here. The t gets to be 0, so it's only these first two terms that you're concerned with, and so 4 plus c2, that's going to be 8. 4 plus C2 is equal to 8, and so therefore C2 is equal to 4. And now, so now that gives you this. That gives you the 4t there. All right, now when you took the derivative, you got these extra 4's there, and so here you're adding 4 plus 4. Yet another color here. You're adding 4 here, and you're adding the 4, let's see, it's still with this, with a C2. C2 is equal to 4. You're adding those 2, and you're getting the 8, and then you're adding, then you're now going to have the 4t, and the 4, yeah, what happens there? The 16 comes because C2 is equal to 4. Or is it, wait, yeah, that's this C2 over here. C2 is equal to 4. And so that's where the 816t comes in. And now, this is the most convenient way to look at it. It's equal to 0. When does it first pass through equilibrium position? Well, just a minute. First passes through the equilibrium position when x of t equals 0. X of t, let's see, x of t equals 0. That's the equilibrium position. Okay, now you're plugging this in, and so you've got either minus 4t, and this you set equal to 0, and, oh, I think that's the velocity, excuse me. Yeah, I'm still, here I'm just giving you some extra information. This is when it actually gets to the maximum stretching, is when t is equal to half, but here the answer is x of t equals 0. That's going to be t equals 1/4. Okay, so that's the way the second one should have been done. Now let's go to, oh yeah, it just skipped a slide because I was a bit impatient. Okay. No, wait, I have to go back one more. Let's see. There it is. This is problem 1. Okay, 24 pounds is equal to 3/4 of a slug. I gave you that information. Stretch is 4 inches, which is equal to 1/3 of a foot. Yeah, 1/3 foot. There it is. 4 inches equals 1/3 foot. And so then we go here. So we put the foot, the K is the 1/3 is what we do about the stretches. Stretches 4 inches, you get this equation, and you plug in the 24, and that's over here on one side, and that's K times the amount of the stretch, which is 1/3, and K is equal to 72 pounds per foot. All right, well, that 7 didn't come out looking too nice. Or wait, what are we doing here? Yeah, this is 72, all right. Yeah, 3/4 x double. Oh yeah, 72 is what this is. Yeah, and then so now we multiply by 4/3, and we get 96x. And now we've got a coefficient of 1 here. And now the r is going to be the square root, yeah, of minus 96. You expect it when there's no damping force to be using, to be having cosines and sines. So okay, this is it. This is your r. Square root of minus 96. And then you're going to have C2 cosine square root of 96t, C2 sine square root of 96t. Now, what else do we need here? So we go ahead and figure out what the C1 and C2 are. X of 0 is equal to minus 1/4. When you plug in 0, the sign drops out. You just have to look at this, the C1 cosine square root of 96t, and so C1 is, and when t is equal to 0, you're taking the cosine of 0, which is equal to 1, and you get a minus 1/4. Okay, so that's your C1. And now C2, you take x prime of t, and you get this deal here. And when you do that, x prime of 0 is equal to 0. You have C1 was equal to minus 1/4. Sine of 0 is 0, so that drops out again. And then you get this extra thing when you're taking the derivative of sine square root of 96t. You have to remember to one different thing here. Let's get red. And so now you have this extra thing here. You took the derivative of the sine and got the cosine. Sine and cosine, square root of 96. Well, you have to take the derivative of the function that you have here. You have to take the derivative of square root of 96t, and of course that's square root of 96. And now you're ready. X prime of 0 is equal to 0 plus the square root of 96 C2. Oh, that should be an equals, wait, square x prime of 0 is equal to 0, square root of it, so it should be plus, yeah, of course, 0 plus the square root of 96. What's really happening here? Okay, yeah. On the other hand, it is equal to 0, so you're getting of course, C2 is equal to 0. And so there you have it. X of t is minus 1/4 times the cosine of square root of 96t. And then the amplitude, you just take C1 squared plus C2 squared. That's easy. C1 squared is equal to square root of it, C1. So you're just taking the absolute value of C1 there. So it's going to be equal to 1/4 or 0.25. In this case, you get an exact decimal. This one, the period is equal to 2 pi over omega 0. That's your square root of 96. And so you divide by that into 2 pi and you get that. Now, this is an optional thing. I don't know if you can see it very easily, but it's optional to rewrite this by saying 4 times the square root of 96t is a little awkward. You get 4 times the square root of 6 times t. But of course, you don't multiply that 1/4 by the 4. You just leave it as is. Okay. Well, we do have some time for Laplace transforms. Let's get going on that. Next slide. Oh, I also wanted to give you a review of some things. So yeah, we might only get as far with Laplace transforms as we did last time, and that's a shame, but I'll give you some practice problems to do on Laplace transforms, which really, well, they do require a little more than what you have, what we've talked about, but after the test, we'll still have 2 classes to go, and so you'll get a decent look at Laplace transforms. Homogeneous second, or see, you're going to be doing not just the problems where you're taking, like on the first quiz, you'll also be going back more further and talking about solving homogeneous equations in general, and so general solution, linear combination of two linearly independent particular solutions, y1 and y2. And the only thing to keep in mind here is you don't want either of these. Linearly independent means, in this case, fortunately, but only two functions are linearly independent and only if neither is a scalar multiple of the other. It's very important to keep in mind that this definition does not work for more than two functions. It's a totally different. Did I lose the slideshow? Looks that way. Let me do this again. Hopefully, we'll get it. Oh, I'm having connection difficulties. All right. Well, let's just hang in there, people. We'll get this thing sorted out. Reconnecting. Okay, looks like well, let's see. Let me get back to this. Looks like I'm going to be able to do something here. Let's see, where do I end here? This one. Oh, I'm waiting for it to upload again. Meanwhile, I'm reviewing what the rest of the PowerPoint presentation is like. Okay, we're going to have to flip through quite a lot of slides to get to the Laplace transforms, but yeah, I might be able to shortcut this thing. Okay. All right. Linearly independent, what that means, linear combination, just all these things, C1, C2. These are the only kinds of linear combinations you have to concern yourself with, just two things. Okay, given two linearly independent solutions works also when coefficients are not constant. This is just for general knowledge, general enrichment. This is not going to, you're not going to be tested on this one. So let's just go on to the next slide. This is slow, and I think it's the all right. Yeah, let's try it again to get to the next. Okay, non-homogeneous equations are where this f of x is not equal to the constant function. Whoop. By the way, this Wronskian will not be, well, yeah. Yeah, no. Yeah, I might do that. It's not that big of a deal, the Wronskian. General solution of this kind of equations is y sub c plus y sub p, except now maybe if Wronskian was introduced in 3.2, then I do want, now, no Wronskians. Anyway, all right, associated homogeneous, and see, it's going to be this y sub c is going to be a solution of the associated homogeneous equation, which is going to be of this form here. Excuse me, this is what I should have focused on. That's your y sub c, and then your y sub p is your y sub p is a particular solution. So that's where that what that role of that y sub p is. Oh no, don't tell me we've lost the slideshow again. Oh my, what are we gonna do here? There we go again. Lesson 8 and share. All right. Well, let's go on here. No Wronskians. No Wronskian needed. Where are we? Here we go. This is the next slide I want you to see. And hopefully it'll come up. Oh, connectivity problems again. Okay, looks like I'm back, and this is where we want to be, talking about the various possibilities of the characteristic equation. You've got the second degree polynomial. There are these three possibilities, and you do have to know, and I'll just have one word problem for you on this one. You will need to know which of these three possibilities it is in order to get off on the right foot. That problem number 2 was about this kind of thing. It was a critically damped thing where you had the same root repeated. And the first problem was like this, but except it didn't have that e to the ax term in it. It just had the c1 cosine bx and the c2 sine bx. So I might give you one damping that's going to have complex roots. Okay, let's go on here. Next slide. Method of undetermined coefficients. This is where you do have this f of x, and the thing is, this is suppose no term. You have to distinguish between these two things, and this is not. You won't get any word problems in it. The word problems come in 3.6, which is not covered in this course. Even it would have been covered perhaps if it hadn't been for that lost week and all the complications that go with online classes. Okay, here's the important thing here. It says, yeah, let's get the red here. Take as a trial solution for a linear combination of all linearly independent such terms. Now, first of all, such terms is terms appearing in f of x or in any of its derivatives. So that's such terms. But then it's to be interpreted broadly. You don't want to take clumsy such terms. You want to take the simplest constant multiples of the terms of f of x. For example, in example 5, which is right here, you've got the 3 to the x cubed, but you don't want to put that 3 there. You just look for an a times x cubed. But then you also have to, and the reason this is important, this part is important to make sure that that 3x cubed does not satisfy the complementary solution y sub c. So derivatives are constant multiples of linearly independent functions. You make those functions as simple as you can, and then you just put, and it gets a little complicated even with that, and then you got that b, ax cubed plus bx squared plus cx plus d. Well, I won't make it that long. But now the thing is, what you do once you've got this, once you have all this, you've got to plug in y sub p prime, and y sub p double prime into the equation. So here you plug in this y sub p double prime down here is plugged into the y double prime, and then there's no middle term, so the only other thing is this first thing that you looked at, this y sub p, and that's going to go in for y there. And you plug that in, and then you use the information that this is equal to 3x cubed in order to solve for all these other things. Now on to the next slide. Okay, the next slide talks about when it does appear, and then you have some work. Let's see. One or more terms duplicates a scalar multiple of some term of y sub c. We need to multiply the solution we would ordinarily try in the case of no duplication by just the highest power of x that will make the duplication go away. If you try higher powers of x, you can get messed up. So here it's, yeah, what happens here, I better look at this. This is example 4 here. Oh, by the way, this example 4 is in 3.2, and I specifically suggest that you, wait, wrong example 4, sorry. Let's go back. I think this is all the way back in example in 3.1, or is it? No, excuse me. Yeah, it has to be with 3.3, because first it talks about, wait, no, excuse me. Again, we have to be in 3.5 where we're doing these things. The first couple of examples, yeah. This is example 4 on page 186. Page 186 is where all this is. And I'll just let you go through that. We're running short of time, so I'm going to go on to the next slide. This is still being recorded. I'll be very careful to leave you with a recording so that you can look back at this if you happen not to have taken your differential equations book with you to wherever you're living now. All right. Most general term, which we might have to deal with, is this sort of thing where you have this polynomial here, uh, and then, but you take the thing that you would ordinarily use. You've got to take all the derivatives of that x to the m, and I'm not going to give you a big M. Don't worry about that. And then you've got this b 0 bx. You've got to also look at derivatives, and the derivative of the cosine is going to be, if you start with the cosine, you're still going to get derivatives involving the sine, unless there's no middle term. Now there, in the first quiz, you didn't have a middle term, and things were simplified, but I might give you one with a middle term, and it is, and then whether you're using one kind or the other kind, you're going to wind up with this whole thing that you have to use. S is the smallest non-negative integer such that no term in y sub p duplicates a term in the complementary function y sub c. Determine the coefficients in equation 15 by substituting y sub p into the non-homogeneous equation. All right, we only have 5 more minutes to go. Obviously, I'm not going to get the Laplace transforms unless, let's see, yeah, I do need to show this again, and then it'll be in the recording, so I'm not going to go too much into detail. The thing is, it's helpful to treat those terms separately because different terms calls for different powers of x, and then you just put together, the f1 of x comes from one term, f2 of x comes from another term, and then some of all the trial solutions for f1 of x and f2, choosing as separately for each part. And so here are the various simplifications. What it did on the previous slide was to give you the most general thing, and here it's giving you some simplified versions where not everything in the general thing appeared. All right, let's see what we got here next. I might have, okay. Let me, that's a blank slide. It was warning me that I need to go further and further. I think it's a good idea. In the quiz, you had to, let's see, hopefully that'll come up fairly quickly. And meanwhile, I'll look at what we had before. Well, there are some details that have to do with the kinds of problems that you had on the quiz, and somehow this doesn't seem to want to go that far. Let's see. Oh, maybe it'll do it. Maybe. All right. Well, let's see. If it doesn't want to keep going, let's just make it. Whew. That's funny. Just as it flashed on the screen, the thing stopped again. Let's see. Back to sharing this thing. Oh boy. Share now. Oh. Okay, only 2 more minutes. Let's see what we can do with those 2 minutes. Yeah. Well, this one, number 20, actually, is what would have flashed on. Oh, no. Okay, looks like we've lost the slideshow and we're out of time. So I think we did okay on this one. And so I did go over the review. The rest, if you want to keep reviewing for the test, just go back to the previous recordings. Well, this is the next slide. Well, anyway, we're out of time. Some students have already left. Just if you want to keep reviewing some of the things that I didn't cover, they're on the recording for last time, and so shouldn't be any problems there. So I'm going to say goodbye. I'm stopping the recording now, and I'm saying goodbye to everybody. You still have one chance to ask a question or say something, but otherwise I'll just be leaving now. Okay, no questions, no comments, so here I go. So long. You will be